Hello class, in this video I will be discussing Module 2, Lesson 1, which is related to kinematics. Okay, all about kinematics. The main topic here is the motion along a straight line. Okay, so all of my discussion for this video is based on the University of Physics with Modern Physics 14th edition by Young and Friedman. So let us start the discussion by um, defining mechanics and its branches. Okay, mechanics is the study of the relationships among force, matter, and motion. So it is the study regarding force, matter, and motion. So when we say mechanics, it is divided into two branches, which is kinematics and dynamics. When we say kinematics, it is the part of mechanics that enables us to describe motion. Okay, uh, sa dynamics naman, it is related uh, to the principles why objects moves in different ways. Okay, so dito describes motion, and dynamics is to understand why objects move in different ways. Okay, so dito sa kinematics guys, mahalaga dito yung modeling. Kung naalala nyo sa previous video is na-discuss natin yung modeling in physics. Kasi you have to plot the worded problem into a model which will be understood clearly. So for example, ayan, ito yung problem. Meron tayong tatlong terms, the displacement, time or time interval, and then the average velocity. Uh, this car is its initial position is P1 at 1 second, okay? And P1, kung ito yung sinet nating datum, yan. Ito yung sinet nating 0 or the start or datum, okay? P1 or the position 1 is at 19 meters from the start position or datum, and then its final position, the car's final position is at point 2, which is 277 meters from the datum or the 0. Okay, and then when we say displacement, okay, pag sinabi nating displacement, that is the change in position. Okay, so when we say change in position, that is the final position or x2 minus the initial position x1. Okay, and then okay, pag sinabi na naman nating time or time interval, that is the change in time. Okay, so that is mathematically that is t2 or the final time minus the t1 or the initial time. Okay, pag sinabi naman nating average velocity, that is the quotient between delta x over delta t. Okay, so in this case or in this scenario, okay, ang delta x natin is the final position, which is 277, minus the initial position, which is 19, okay, meters. And that is equivalent sa 258 meters. Okay? And then the delta time or the time interval, that is from the 4.0 seconds to 1.0 seconds, and that is equivalent to what? 3.0 seconds. Okay, pag sinabi naman nating average velocity, we have to divide this two. Okay, VAV, okay, equals 258 divided by 3.0 seconds, which is equivalent to 86 meters per second. Okay, dito sa physics guys, importante din na sinusunod natin yung significant figures. Okay, sabi dito, pag nag-subtract tayo ng delta x, okay, di ba pag subtraction, ang tinitingnan is yung decimal point. Since wala silang decimal point, ang sagot natin walang decimal point. Okay? Same here. Sa 4.0 seconds minus 1.0 seconds, ang tinitingnan yung decimal point, which is may isa. So, yung sagot natin dapat is may isang decimal points. Pag nag-divide naman tayo, we have to consider the fewest significant figures, which is, in this case, 258 divided by 3.0. 3.0 has two significant figures. 258 has three significant figures. So, ang isusundin natin itong two significant figures. So, kaya siya walang decimal point, which is 86 meters per second. Okay? So, that is how we compute kinematics in physics. Okay? Next, ayan. So, kung mapapansin nyo dito sa first example, from the zero position or the datum, the car is going to the right. Or, let's consider this as the positive x-axis. Okay? So, paano naman guys kung nag-set ka ng datum, kung nag-set ka ng datum, but the particle is going or going towards the uh, datum, okay, or the zero position. So, anong mangyayari? Ang mangyayari dyan guys is malamang dahil ang delta x natin ay magiging ang second position na natin dito is 19 meters. 19 meters minus ang initial position na ng car is 277 meters. Okay? So, dito pa lang negative na siya. Negative 258 meters. And then, the delta t, 25 minus 16. Okay? So, this is equivalent to 9.0 seconds. So, pag pinag-divide natin siya to get the velocity, okay, ang magiging velocity natin is magiging negative. Okay? Magiging negative siya in such a way. Ang ibig sabihin is the car or the particle is going towards the direction of your datum or decreasing position, decreasing distance. Okay? So, that's how the sign convention is used. Okay? Yun ang ibig sabihin. So, you just need to understand na kapag ang x-coordinate natin is positive, okay? Halimbawa, ito yung positive x. And then the particle is going more positive. Ang velocity natin is positive, okay? And kung halimbawa, ito si positive x, pag ang particle natin is going or decreasing positive, going to the left or towards your datum, ang velocity natin is negative v. Okay? Pero naman, kung halimbawa ang coordinate natin is negative x, nandito tayo sa x coordinate, okay? Negative x coordinate, kapag ang particle natin is going to the right or going to the datum, or getting less negative, okay, less negative, ang velocity natin is positive, okay? Pero, kapag ito ang negative x natin at lalo pa siyang lumalayo, okay, getting more negative siya, so, ang velocity natin is magiging negative. Okay? So, ito yung sign convention, rules for the sign of x velocity. Okay? Ayan, ito naman is, it is how you graph the x and time function. Okay? So, kung ito yung initial position natin, ito yung final position at time 1, time 2. Ito yung function mo. Okay? And then, the slope is equivalent sa average x velocity. Why? Kasi ang slope is rise over run, which is equivalent also to delta x over delta t. Okay? So, ano lang to? Graphing. Okay? Next, when we say instantaneous velocity naman, it is the velocity of the particle at a specific instant of time or specific point along the path. Okay? Kung ang average velocity, okay, yan ang average. Average velocity. At ito naman si instantaneous velocity. We denote this as Vx only. Ayan. Pag sinabi nating average velocity, ito yung velocity niya or average mean velocity niya at the given time interval or delta t. Okay? Pag sinabi naman nating instantaneous velocity, ito yung velocity at a certain point of time. Okay? At a certain point or time. O halimbawa, at point x, ito yung velocity niya. At this time, ito yung velocity niya. Ito naman is the average velocity from, let's say, from time 1 to time 2. Okay? The change in time or the mean velocity at the given interval. Okay? At ang formula ng average velocity is delta x over delta t. Okay? Dito naman sa Vx, it is the change in the position over change in time wherein the limits would be delta t is approaching 0. Okay? Or it can also be solved using dx over dt. Okay? So, instantaneous velocity is the velocity at a given time or at a given position. Ang average velocity is the mean velocity at an interval of time. Okay? So, let us be reminded ulit. Okay? Let's be reminded. Okay, sorry. Na ang sign convention ng velocity ay depende dun sa datum na ginawa mo. Kung ito yung positive x mo, okay, at ang particle mo is going to the datum, going towards the datum, negative ang velocity. Kapag halimbawa ito si positive x, depende yan sa iyo eh. Kung ito si positive x at ang particle mo ay going palayo sa datum, basta palayo sa datum, ibig sabihin, or palayo sa zero, ibig sabihin, the velocity is positive. Pero kapag yung particle is going to your zero or going to the datum, towards the datum, the velocity is negative. Okay? The sign conventions are would depend on your datum. So let's say for example, let's apply that in example number 1. Okay. Sabi niya, a cheetah, a cheetah is crouched 20 meters to the east of a vehicle. At time 0, the cheetah begins to run due east towards an antelope that is 50 meters to the east of vehicle. So, in order to solve a physics problem, worded problem in kinematics, we have to draw the model, okay, which will represent the worded problem. Okay? So, sabi niya, a cheetah is crouched 20 meters to the east of a vehicle. Okay? So, let's say, for example, ang datum natin is nandun sa vehicle. Yan. Tapos, sabi niya, 20 meters east of the vehicle, merong cheetah. Okay? During the first, at time 0, so 20 meters, ang x1 natin is 20 meters times 0. Okay. At time 0, si cheetah ay 20 meters na from the vehicle. Okay. And then, towards an antelope that is 50 meters to the east of the vehicle. So, meron daw antelope dito. Antelope. X2 is 50 meters. Okay? 50 meters from the vehicle or the datum. During the first 2 seconds of the chase, the cheetah's x-coordinate varies with time according to the equation. So, may given na equation. Yung x-coordinate daw ni cheetah ay magva-vary sa ganitong equation. 20 meters plus 5.0 meter per second squared. Okay? And then t squared. Yan. Find the cheetah's displacement between t1, 1.0 second and t2, 2.0 second. Okay. In letter A, we are to find the displacement or delta x at time 1.0 second and time 2.0 second. Okay. ano na ulit yung x natin? X is 20 meters plus 5.0 meter per second squared t squared. Okay. So in order for us to know the position x1, we have to substitute uh, t1. T1, this is t2. Yeah. So x1 is equivalent to 20 meters plus 5.0 meter per second squared. T squared is what? 1.0 second and then squared. So 20 plus 5 times 1 squared. Okay. That is 25. So applying the significant figures, you have to follow still the significant figures, okay? So 1.0, 5.0, we have two significant figures here. So the result of this product is two significant figure with one decimal. When we are adding, we will look upon the few decimal places. This has the few decimal places because it contains no decimal places. So dapat ang sagot natin is wala tayong decimal places. So 25 meters. Alright. So 25 meters ang x1 natin. So how do we compute for x2? Siyempre, we just have to substitute T2, okay? 20 meters plus 5.0 meter per second squared, 2.0 seconds squared. Okay. Then, x2, we have to compute. Palitan lang natin to ng 2. 40. Alright. 40. Same principle yung significant figures, okay? So, ang sagot lang natin is 40 meters. And then, we just have to solve for delta x, which is x2 minus x1. That is 40 minus 25. And that is equivalent to what? 40 minus 25 is equivalent to 15 meters. Alright. So, this is our final answer. Okay? For letter A. So, next is letter B. Find its average velocity during the interval. We are asked to find the V average. Okay? And V average is equivalent to delta x over delta t. Ang delta x natin is 15 meters. Ang delta t natin is t2 minus t1. Okay? 15 meters, t2 is equivalent to 2.0 seconds minus 1.0 seconds. Okay? That is equivalent also to 15 meters per second. Okay? Applying the significant figures, we have the fewest, which is two significant figures. So, voila. This is the final answer. So, next, letter C. Find its instantaneous velocity. We have to find Vx at t1 seconds. So, ano daw yung instantaneous velocity niya at exactly 1.0 seconds? By taking delta t 0.1 second and delta t 0.01, then 0.001. Okay. 0.01 second and lastly is 0.001 second. Okay. Ma'am, ba't ang dami pong delta t? Diba nga, ang instantaneous velocity kasi is the limits of, delta t approaching 0, okay, of delta x over delta t. We have to get the change of the distance or the position wherein the time interval is approaching 0. So, kung mapapansin nyo, first is 0.01, 0.01, I mean 0.1, 0.01, and then 0.001. Diba? Approaching 0 yan. Okay? So, let's just apply that here. Okay? Paano natin maa-achieve ang 0.1 seconds na time interval? So, basically, kailangan natin ng delta t na 0.1. So, dapat ang final time natin T2, sorry. Ang T1 natin is 1.0 at ang T2 natin dapat is 1.1 second. Okay? Pag pinag-minus mo sila, that will be equivalent to 0.1 seconds. Tama ba? Okay. So, we can now look for the average first. Okay? The V average, which is delta x over delta t. But we have first to find x2 or the x at 1.1 seconds. Okay? X 1.1 seconds, x at 1.1 seconds is equivalent to 20 meters plus 0.50 meter per second squared, 1.1 second squared. So, x is equivalent to x2 here, x2. Okay. It's equivalent to 20 plus 0.5 times 1.1 squared. That is equivalent to what? 20.605. Okay. Kung mapapansin nyo guys, I neglect to apply the significant figures here because we are trying to get the smallest significant or the smallest change in x at the smallest change in time. Okay? So, kailangan i-put natin or kunin natin yung buong answer. Okay? Namatay. Sorry. Where is it? Kunin natin yung buong answer nung nito muna, and then later on we just have to apply the significant figure. So for now, dahil kumukuha tayo ng very small delta x at delta t, we just have to consider the whole answer, okay, including all the significant figures that it has. So x to 20.605. Okay, so in that case, v average in that 0.1 second interval, okay, is 20 point, what is that? What's the final answer? I'm sorry. 20.605. Okay. 20.6, tama ba? Oh, wrong. Okay, mali pala to. Sorry. Mali pala yung given na ma'am. This should be 5.0. Okay? So, let's recompute. 20 plus 5 times 1.1 squared. Okay. So, that is 26.05 meters. Okay. So, okay. So, alam naman natin kanina na ang x1 natin at 1 second is equivalent to 25 meters, di ba? So, ang x2 natin at 1.1 second is equivalent to 26.05. So, getting it, 26.05 minus 25 meters divided by 0.1 seconds or 1.1 minus 1. Okay? So, that should be equivalent to what? 26.05 minus 25 divided by 0.1. 10.5. Okay. 10.5 meters per second. Okay, good. Now, the next one is our delta t should be 0.01 second. Okay? So, in order to have that, ang T2 natin dapat is 1.01 second. Ang T1 natin is 1 second. Diba? Para magkaroon tayong change of time na 0.01. Okay? So, we have first to know what is x2 at 1.01 seconds. So, kanina, we just have to use the function 5.0 meter per second squared 1.01 squared, okay? Then x2 should be equivalent to 20 plus 5 times 1.01 squared, okay? That is equivalent to 25, 1005 meters, okay? So, kinukuha ko nga lahat yung buong answer kasi we have to consider all the smallest change in x and time, okay? So, the average here is what? X2 is 25.1005 minus 25 over 0.01. So, this is equivalent to 25.1005 minus 25 divided by 0.01. Right. Okay. So, that is equivalent to 10.05 meters per second. And lastly, kunin natin yung interval na 0.001. So, we have to, ang T2 natin dito is 1.001 seconds. Ang T1 natin is 1.0 seconds. And, ano pa ba? We have to get the x2 here at 1.001 seconds. So, 20 meters plus 5.0 meter per second, 1.001 squared. So, ang x2 natin here is 20 plus 5 times 1.001 squared. Okay. 25.010005. Okay. So, getting the average. Okay. Getting the average. That should be 25.010005 minus 25 over 0.001. Okay. So, let's compute. Okay. 25 over 0.001. So, that is equivalent to 10.005. Okay. 10.005. Okay. So, we have 10.05, 10.005 meters per second, and 10.5 meters per second. Okay. So, if we are going to compare that, okay, 10.5, 10.005, and 10.005. And if we are going to follow the significant figures now, okay, kung titingnan natin yung significant figures natin, we have to follow pag-product, diba? The fewest. So, ang fewest dito is 1, 2, 3, 1, 2. So, ito. And then, pag-addition naman, we have to follow the decimal point. Ang walang decimal point or the fewest decimal point is 20 meters. So, dapat meron tayong 0 decimal point. Okay? So, kapag tinignan natin, considerably 10 meters per second, okay, is the instantaneous velocity at time 1.0 second. Okay? 10.005, 10.05, 10.5. Okay? So, makikita nyo dito, ayan, 10, roughly, ang instantaneous velocity ay naglalaro sa 10 meters per second. Okay? Pag kinuha mo din yung average ng tatlo, that is 10.18. Pag kinuha natin yung average, diba? 10.5 plus 10.05 plus 10.005. Pag in-average natin siya, 10.1. So, 10 meters per second pa din. Okay? So, ganun siya. Kapag ganyan yung method. Okay? Next, sa letter D, okay, sa letter D, derive an expression for the cheetah's instantaneous velocity as a function of time and use it to find Vx at t is equals to 1.0 seconds and t is equals to 2.0 seconds. Okay. Sabi sa problem, dito na lang tayo mag-solve kasi wala nang space. Okay. Sabi sa problem, we have to derive, di ba meron tayong formula na 20 meters plus 5.0 meters per second squared t squared. I-derive daw natin to in such a way na makuha natin si instantaneous velocity at time 1.0 second at saka time 2.0 second. Okay? Okay. So, ang gagawin natin is, if you will remember, Vx is equivalent to dx over dt, diba? Okay. So, ang meron tayo is function of x. So, ito ang meron tayo. So, ibig sabihin, we have to derive that in order to have Vx. So, 20 plus 5t squared. Okay? So, ang Vx natin is the derivative of this. 20 is a constant, so that is 0. Plus, we have to bring down 2 times 5 times t. So, Vx is equivalent to 10t. Tama ba? Okay. So, dahil dyan, Vx, so, ito ay 5.0. Okay. 10t, yan. So, 10t, we have to just, ito na yung function natin for the Vx. So, we just have to substitute 1 second. So, Vx is equals to 10 times 1.0 seconds. Okay. So, ang Vx natin is 10 meters per second. Okay. Tama yung na-solve natin kanina. Paano naman kapag 2 seconds? Vx is equals to 10, 2.0 seconds. Okay. So, Vx is equivalent to what? 20 meters per second. Okay? So, that is how you can solve the derivative or the function, the Vx, using the derivative or the derivation of the function x. Okay? So, next, let us discuss acceleration. So, let's just scratch this one. Okay. When we say acceleration, it is the rate of change of velocity over time. Okay? Rate of change of velocity of time. Ang velocity is the rate of change in x over time. So, magkaiba yun. So, pag sinabi nating average velocity, average acceleration rather, that is the change of velocity over the change of time. Kapag instantaneous naman, that is the actual acceleration at the given point of time. Okay? So, parang ano lang yan, instantaneous velocity. Velocity at a given time, acceleration at a given time. Okay? So, it is denoted by this one and this one. Okay? So, let's proceed. So, the rules for the sign of acceleration. Ay, sorry. Burahin muna natin. Okay. Sabi niya, kapag ang x velocity is positive and increasing, the x acceleration is positive. Okay? At saka, kapag ang initial velocity mo, tandaan to ha, pag ang initial velocity mo ay positive at ang acceleration mo ay positive, that is speeding up. Okay? Okay. So, kapag ang x velocity mo ay positive and decreasing, okay, decreasing velocity, your acceleration is negative. At kapag ang initial mo ay positive at ang acceleration mo, initial velocity mo ay positive at ang acceleration mo ay negative, that is slowing down. Okay? So, kapag ang velocity mo ay negative and increasing, okay, negative and increasing, your acceleration is positive. The negative sign refers to the direction, which is going to the negative x direction, or going to the datum, towards the datum. So, kapag negative to, ang initial velocity mo ay negative at ang acceleration mo ay positive. Okay? That is slowing down. Basta magkaiba ang sign ng velocity initial at ng acceleration, opposite or magkaiba ng sign convention, that is slowing down. Pag parehas, negative, negative, that is speeding up. Okay? Okay, sige. You just have to remember that. So, let us apply that in example number 2. Sabi dito is, an astronaut has left an orbiting spacecraft to test a new personal maneuvering unit. As she moves along a straight line, her partner on the spacecraft measures her velocity every 2 seconds, starting at time 1.0 seconds. Okay? So, ito yung values na nakuha niya, data. Find the average x acceleration and state whether the speed of the astronaut increases or decreases over each 2 seconds time interval. So, sa letter A, 1 second to 3 second. Okay. Let's solve. Time is 1.0 second, T1 yan. T2 is 3.0 second. Kunin daw natin si average acceleration. Okay. And then, we have to identify kung speeding up siya or decreasing. So, ang velocity natin at 1 second, 0.8 and then 1.2. Okay. 0.8 meters per second, and then velocity 2 is 1.2 meters per second. Okay? Then, we have to get the average velocity, which is delta V over delta T. Ang delta V natin is V2 minus V1 over T2 minus T1. Yan. 1.2 minus 0.8. Okay. T2 is 3.0. T1 is 1.0. Okay. So, kapag kinalki natin siya, 1.2 minus 0.8, that is equivalent to 0.4 meters per second. Okay. And then, 3 minus 1 is 2.0 meters per second. So, 0.4 divided by 2, that is equivalent to 0.2. Positive 0.2 meters per second squared. Okay. Now, how do we identify if it's slowing down or speeding up? Ang initial natin is positive, ang acceleration natin is positive, so therefore this is speeding up or increasing velocity. Okay. So next, let's proceed to letter B. Ano ba si letter B? Sabi niya, sa letter B is interval 5 to 7. Okay. 5 to 7, 1.6, 1.2. 5, 1.6, 7, 1.2. Okay. T1, V1, 0.0 second meters per second. T2, 0.0 seconds. This is V2 meters per second. Okay. So, ano bang gagawin natin dito? Ayan. So, ang gagawin natin is, kunin ulit si average. Okay. So, that is equivalent to 1.2 minus 1.6 over 7.0 minus 5.0. Meters per second, seconds, seconds. Okay. So, 1.2 minus 1.6 Ganun pa din, negative 0.4, okay, over 2.0, sorry, this is seconds, nakita ko na yung mali, okay, 2.0 seconds, and then ito ay equivalent din sa negative 0.2 meter per second square. Ito naman, dahil negative siya, ibig sabihin, um, dahil ang initial velocity natin is positive and this is negative, magkasalungat sila, magkaiba sila ng sign convention, so ibig sabihin this is speeding down or decreasing, slowing down pala, speeding down, okay, slowing down, ayan, or decreasing velocity, okay. Okay. So next, example number 2. Yan. Okay. Example number 2. Dun pa din, letter C. Yan. Sa time interval naman na 9.0 second hanggang 11.0 second. Okay, ang V1 natin dito, 9 seconds ay negative. Guys, kapag ang velocity ay negative, ibig sabihin going towards the datum siya, okay? V2 is, so itong negative 1.0 meters per second ay going to the datum, okay? Pati itong negative 0.4. And then we have to get the average acceleration. That is negative 1.0 minus meters per second minus negative 0.4 meters per second over 11.0 seconds minus 9.0 seconds. That is negative 1.0 minus negative 0.4. That is negative 0.6. Okay. Negative 0.6 meters per second divided by 2.0 seconds. So this is negative 0.3 meters per second squared. So negative, negative. Okay. Pag pares ng sign convention, this is increasing acceleration or speeding up. Okay. Now, next, letter D. Okay, letter D is T1 is 13.0 second. Ang T2 natin is 15.0 second. Sa letter D, 13, negative 1.6, negative 0.8. Negative 1.6, negative 0.8 meters per second. Okay. So, what do we do? Ganun ulit. Napakadali, diba? Average acceleration, negative 0.8 meters per second, meters per second minus negative 1.6, minus negative 1.6 meters per second over 15 minus 13, that is 2.0 seconds, okay? So, negative 0.8 minus negative 1.6 equivalent sa what? 0.8. Okay, positive 0.8 meters per second over 2.0 seconds. So that is 0.4 meters per second squared. Positive, negative. So ibig sabihin slowing down or decreasing velocity. Okay? So ganun lang kasimple. So let's proceed to example number 3. Yeah. Suppose that x velocity vx of the car at any time t is given by the equation vx. So ito ay instantaneous vx. Ayan o. X velocity vx at any time. Okay, so nagbigay siya ng function. Find the change in x velocity of the car in the time interval. T1 equals 1.0 seconds and T2 is equals to 3.0 seconds. Okay. Hanapin daw natin, sa letter A, hanapin natin yung change in velocity at time 1.0 second at saka time 3.0 second. At ang given function natin is 60 meters per second plus 0.50 meters per second cube, okay, t squared. So, para makita natin yung v at 1 second, t at 1.0 second, palitan lang natin tong time ng 1.0 second. So, 60 meters per second plus 0.50 meter per second cube 1.0 second squared. Okay. 60 plus 0.5 1.0 squared. So that is equivalent to 60.5. Okay. Following the significant figures, we have here this fewest significant figures in the product. So, 2, 1 decimal place. Pag mag-a-add naman tayo, ito yung susundin natin kasi ito yung fewest decimal place, which is wala. So, dapat ang Vx natin ay equivalent sa 61 meters per second. Okay? Then, next, hanapin naman natin yung Vx at time 3.0 seconds. So, papalitan lang natin ng 60 meters per second plus 0.50 meters per second cube. Palitan natin siya ng 3.0 second squared. Okay? So, palitan lang natin to ng 3. That is equivalent to 64.5. Okay? Or, pag finalo natin, dapat ito pa din ang masusunod. Okay? That is equivalent to 65 meters per second. So, delta Vx is equivalent to 65 minus 61. Oops, don't forget the units. Meters per second minus 61 meters per second. So, that is 64. That is equivalent to 4 meters per second. Okay? So, that is for letter A. So, for letter B, find the average acceleration in this time interval. Okay, so sa letter B, average acceleration. So that is delta V x over delta t. So that is 4 meters per second over 3.0 seconds minus 1.0 seconds. That is 4 meters per second divided by what? 2 0.0 meters per second. Ang susundin natin is fewest, which is this one. So that is equivalent to 2 meters per second. Okay. 2 meters per second. Okay. So, let's check kung sinusunod natin. Okay. So, ito pala guys. Ayan. Okay. Tama lang pala. Tama lang pala siya kasi nag-subtract pala tayo. So, pag nag-divide the fewest, okay. So, pasok doon si 2. Okay. Next, letter C. Letter C is find the instantaneous acceleration at time t1, which is 1 second by taking delta t 0.1, 0.01, 0.001. Okay. So, ang hanap natin is AX or the instantaneous velocity, which is equivalent to the delta Vx over delta time, which is approaching 0. Okay. So, in order to have, kasi 'di ba at time 0, ay at time, At time ano tayo? 1.0 seconds. Okay. So, pag ang change natin is 0.1, so we just have to find the acceleration at or sorry. we just have to find the velocity at 1 second, and then the velocity at 1.1 seconds. So, di ba, we need T2 at 1.1 in order to have 0.1 delta T. Okay? So, we know na ang V1 natin is equivalent sa 61. Kasi na-solve na natin yan kanina. Ito siya. Ayan. At 1 second. Okay. 61. Or, pag dito pala guys, we need to consider the whole answer kasi we are dealing with very few change or very small change. So, 'di ba ang Vx natin ay 60 meters per second plus 0.5 meter per second cube t squared, okay? At time 0 or V1 time zero, at time 1 second pala. At time 1 second, okay, or V1, the V1 is 60 plus 0.5 times 1. Okay? So, our 60.5. So, pag ganito guys na we are dealing with delta na very small, pag kinukuha natin yung instantaneous at given tayo ng mga delta na 0.1, ganyan, very small change, we have to consider everything. So, this is 60.5, okay. Pag V2 naman natin, which is at 1.1 seconds, so, palitan lang natin ng 1.1 seconds to. Okay. So, palitan lang natin. Okay. 60 point. V2 is 60.55. Okay. 55. Ay, sorry. May squared pa pala yun. Squared. Sorry. 60.605. Okay, rather. 60.605 meters per second. So, if you're going to get the average velocity, average acceleration, that is delta V over delta T, 60.605 minus 60.5 divided by 0.1. Ang average velocity natin for that interval is 0.1. That is 1.05. Okay. That is 1.05 meters per second squared. Okay. So, pag 0.01 naman, okay, the next, sorry. Okay, the next interval we have to get is at 0.01. So, para magkaroon tayo ng ganyan, ang final natin is 1.01 seconds. T1 is 1.0 seconds. Ang V1 natin, we know, na-solve na natin to. This is 60.5 meters per second. So, we are only to solve V2, which is 60 meters per second plus 0.50 meter per second cube T squared. Equivalent ito ng 1.01 squared seconds. Okay. So, solve natin. 60 plus 0.5, 1.01 squared. Yan, 60.51005. Okay. So, ang average velocity natin dito, or average acceleration pala. Okay, sorry. Ayan. Is V2 is 60.51005. Okay. And 60.5. Take note. Kinukuha ko lahat ng figures kasi this is very very small change. Okay. Minus 60.5 divided by 0.01. Okay? Ang average velocity natin, ay average acceleration, okay, is equivalent to 1.005 meters per second squared. How about pag ang change naman natin ay 0.001? Okay? So, ang time natin, T2 natin, ang kailangan is 1.001 second. T1 natin is 1.0 second. So, ang V2, 60 meters per second plus 0.50 meters per meters per second cube, 1.001, okay, squared. That is equivalent sa V2 na 60 plus 0.5 times 1.001 squared. 60.50100005. Okay, and then we have to get the average acceleration. Okay, 60.50100005 minus 60.5 over 0.001. Okay, let's compute for that. Okay, answer minus 60.5 divided by 0.00, tama ba? 0.001. Okay, that is equivalent to 1.00 average 1.0005. Okay, so kung i-compare natin this one, 1.005 1.005 meters per second squared, and then the other one is what, 1.05. Okay, roughly, okay, ang sagot natin na instantaneous acceleration at 1 second is 1.0 meters per second squared. Okay, so that's it. Next is what? Meron pang isang tanong. Letter D. Derive an expression for the instantaneous x acceleration as a function of time and use it to find ax at 1 second and 3 seconds. Okay. So, dito na natin sagutin sa gilid. Yan. Okay. Diba ang given nating function is vx at 60 meters per second plus 0.50 meters per second cube t squared. Okay. And then we all know that instantaneous acceleration is dvx over dt. Okay. And we have vx here. So, ibig sabihin, we have to derive the vx, 60 meters per second plus 0.5 meters per second cube t squared. Ayan. So, when we derive that, ito, dahil constant 0, ito ibababa mo yung 2. So, 2, 0.50 meters per second cube t. Yan. Okay? So, ang acceleration na natin ngayon is 0.5 meters per second cube t. This is the function of acceleration. So now, para makuha natin yung acceleration, instantaneous acceleration sa 1 seconds at saka sa 3.0 seconds, we just have to substitute dun sa t. Okay, so ax at 1 second is 2 times 0.50 meters per second cube times 1.0 second. So that is equivalent to 2 times 0.50 times 1.0. So 1. Okay, that is equivalent to 1.0 meters per second squared. Okay, now Sa 3 seconds naman, AX, 2 times 0.50 meters per second cube and 3.0 seconds. So, papalitan lang natin. Oops. Okay. Papalitan lang natin to ng 3. That is 3 seconds. So, ang AX natin ay equivalent sa um, 3 3.0 meters per second squared. Okay. So, bakit 2 decimal or 2 significant figure? Kasi ito hindi na siya kasama dahil algebraic function na siya. Hindi siya measurement. So, ito na lang ang basihan natin sa product. At ito ang may fewest na significant figure. So, ang sagot natin ay 2 significant figures din. Okay? So, next, dito na tayo sa motion with constant acceleration. Okay, so we have here 1, 2, 3, 4. 4 formulas. Okay, 4 formulas to memorize. Okay, or you just have to understand how it was derived. Okay, so guys, i-solve natin siya para maintindihan nyo siya kung saan galing. Diba, we have this equation earlier na v is equals to dx over dt. Okay? And then, we have here a equals dv over dt. Okay. Take note guys na itong formulas na to ay gagamitin nyo lang kapag ang motion natin is constant acceleration. Pag sinabi natin constant acceleration, your acceleration is, or the change in your velocity is constant, okay, at a given interval. Kahit anong interval yan, constant pa din yung acceleration, okay? So, pag hindi constant yung acceleration, you cannot apply this formula. So, take note na dapat constant acceleration yung problem. Okay? So, yung 4 formulas na yan ay galing dito. Okay? So, ayan. V is equals to dx over dt. And then, A is equals to dv over dt. Okay? Dito tayo mag-uumpisa sa acceleration. So, we just have to cross multiply. A dt is equals to dv. Tama ba? Okay. Given tayo dito na ang time natin, initial time natin is 0 seconds, ha? Okay. Given yan. Okay. So, dahil ang acceleration natin ay constant, let's put subscript na c para indicate that is the acceleration is constant. Okay, we can integrate both sides, okay, by this one. So dahil constant to, ayan, AC labas natin, dt equals integration of dv. Ito ay from 0 to t, okay, dahil ang initial time natin is always 0 seconds. And then, ito naman ay initial velocity to final velocity. Okay? So, when we integrate dv, that is equivalent to v, which we can evaluate from v0 to vf. Okay? And then, ac, t, dt is, the integration of dt is t, and evaluate it from 0 to t. Okay? So, AC, diba? T final minus initial, 0 seconds. Okay? And then, evaluate this from VF minus V0. Ayan. Okay? So, our final formula, ACT is equals to VF minus V0. So, VF is equivalent to V0 plus ACT. Ayan. Meron na tayong first formula, which is what? This one. Ayan. Okay. Ma'am, bakit po Vx yan? Bakit may x? Kasi 'di ba, we are discussing right now is what we are discussing right now is motion at in a straight line, motion in a straight line, or we can say that is positive x muna or negative x. So that is, this is the velocity in x direction only. Okay. Okay? So meron na tayong first formula. Now, okay. So dahil meron na tayong given na ganito at magagamit na natin ito, okay, ayan. Pwede nating i-substitute si v dx over dt. We can substitute v as vox plus act dx over dt. Okay? And then, cross multiply vox plus act dt is equals to dx. And then, we can integrate both sides again. Okay? And then, ano pa? Pag in-integrate natin yan, pwede nating paghiwalayan. Sorry. Paghiwalayin natin siya para mas madali. Vox dt plus integration of ac t dt is equals to integration of dx. So, pag in-integrate natin to, given na ang Vox ay may value na, so ito na ay constant. So, ang mangyayari dyan, ilalabas natin si Vox dahil may value na yan ha. dt plus AC t dt is equals to dx. Okay? So, Vox t, okay, and this is evaluated from 0 to t ulit, plus AC 1/2 t squared evaluated from 0 to t equals to x evaluated from x0 to x. Okay. Okay. So, let's simplify. This will be Vox t minus 0 seconds plus AC 1/2 t squared minus 1/2 0 seconds squared. Okay, and then x minus x sub 0. Okay, so simplify natin. Plus AC 1/2 t squared equals to x minus x sub 0. Then let's transfer x equals to x0 plus Vox t plus 1/2 AC t squared. Okay. So, meron na tayong equation 2. Okay? Ang equation 2 natin is, meron na tayo nito at meron na tayo nito. Okay. So, sa equation 3, ma'am, paano niyo po kinuha yung equation 3? Kung mapapansin niyo, wala siyang function of x. So, ang gagawin natin is, gamit yung dalawang formula ulit na v is equals to dx over dt at a is equals to dv over dt. Dahil wala siyang function of time, okay, alisin natin yung function of time. Yan. Pag-equatein natin, dt, dt, so equate na lang natin. dv over a. Yan. Okay. So, cross multiply a dx v dv, and then now we can integrate both sides. Okay? Dahil constant to labas natin. dx equals v dv. Yan. So, pag integrate natin itong side na to, this is ax. Ito ay from x0 to x final. Okay? Then ito ay from v0 to v final. So, ax evaluated from x0 to x final equals v squared over 2. Tama ba? Yan. v0 from v final. So, meron tayo ditong a xf minus x0 final minus initial is equals to v squared over 2 final minus v0 squared over 2 initial. Okay? To simplify further, ang mangyari dyan, iakyat natin si 2 sa taas. 2a xf minus x0. Ito magiging vf squared minus v0 squared. Ayusin lang natin. Vf squared is equals to v0 squared plus 2ac xf minus x0. Okay. So, yan na yung equation number 3. Ayan. Oops. Yan. So, may equation number 3 na tayo. So, yan. Oops. Yan. Ito yung number 3. So, paano naman yung 4? Okay. Yung 4 naman, yung 4 naman is makukuha natin by what? Anong gagamitin natin? Diba? May formula tayong v dx over dt tsaka a dv over dt. Yan. So, meron na tayong acceleration, meron na tayong v, meron na tayong dx, okay. So, diba, ang acceleration natin ay equivalent sa yung gamit tong formula na to. Wait lang May formula tayo sa 1 na v f is equals to v0 plus 80. At ang acceleration natin ay equivalent sa v f minus vo over t, diba? Okay. So, ito pwede nating i-substitute here. So, vf minus v0 t dv over dt. Yan. Okay. Tapos, meron na tayong ayan. Sika lang Ito yung acceleration. Sorry. Ito yung acceleration. And then, di ba may formula tayo dito na this one. Ayan. Yan. Yan. Okay. So, pwede nating palitan yan. Magiging x is equals to x0 plus voxt plus 1/2. Then, palitan natin to ng vf minus v0t t squared. Ayan. Yan. Okay? So, x is equals to x0 plus voxt, okay, plus 1/2 magiging vf minus v0 t na lang to. Okay? Then, pwede nating ayusin siya as ganito, x minus x0 equals voxt plus 1/2 vf minus v0 t. Yan. So, ito ay v0x to. Yan. X yan lahat. Okay? Ito at ito ay parehas na term, diba? So, 1 minus 1/2, that is positive 1/2. So, may matitira dito na 1/2 vfx plus voxt. Yan. So, ito na yung fourth equation. oops, where is it? Ayan, ito na yung fourth equation. Diba? Pares lang. Okay. So, yan, paalala lang, ginagamit lang yan kapag constant ang acceleration. Okay, so let's apply. Ayan. Example number 4, a motorcyclist heading east through a small town accelerates at constant 4 meters per second squared. After he leaves the city limits, at time t equals 0, he is 5 meters east of the city limits signpost while he moves east at 15 meters per second. Find his position and velocity at 2.0 second. Where is he when his speed is 25 meters per second? Okay. So, tingnan muna natin yung equation. Meron daw siyang constant acceleration of 4 meters per second squared after he leaves the city limits. Okay? At time 0, he is 5 meters east of the city limits. So halimbawa, ito na. Signpost. Ito yung signpost, yan yung 0. At time 0, 5 meters na siya. Okay? He moves east at 15 meters. Okay. Time 0, ang velocity niya ay 15 meters per second. Okay. So, find his position and velocity at t is equals to 0. So, find its position and the velocity, final velocity at t is equals to seconds. Okay? So, anong gagawin natin? Kailangan natin ng formula ng x, vf, at saka, yan, x saka vf. Yung vf, diba, we can solve it by, diba may formula tayo kanina na vf is equals to v0 plus 80. So, vf is equals to 15 meters per second. Ilang significant figure yun? 15, 2 significant, plus, ang acceleration niya ay 4.0 meter per second squared times 2.0 seconds. Tama ba? Let's just verify. Okay. Now, the final velocity at time 20 seconds is 15 plus 4 times 2. That is equivalent to 23. 23 meters per second. Okay? So, let us consider this as the significant figure kasi siya yung konting decimal or walang decimal place. So, ito na yung VF natin for letter A. Okay? And then, hinahanap din yung x. Okay? So, may formula tayo na xo plus vot plus 1/2 at squared. So, direct sub lang, xo is 5 meters, diba? Tama ba? Sa alala ko, that is 5 meters. Ayan o. Ang initial niya is 5 meters. So, let's consider the significant figure. 5.0 meters plus VOT na 15 meters per second times time na 2.0 second plus 1/2 times 4.0 meters per second squared, then 2.0 seconds squared. Okay? Ang x natin is what? 5 plus 15 times 2.0 plus 1/2 times 4 times 2 squared. Ang sagot niya is 43. Tama ba? Okay. Ang sagot niya is 43 meters. Okay. Now, let's check kung tama yung significant figure natin. Dito, 2 significant figure. Ito is two significant figure. Ito ay two significant figure. Okay. Pero this one, 15 times 2, this is 30. Okay, 30. Ito ay 5.0. Ito ay may 0.010. So, we just have to follow yung walang decimal place. Okay? 43 meters. Okay. Yan. Now, okay na tayo sa letter A. Tama ba? Okay na tayo sa letter A. That is the okay. A finds okay. Where is he when his speed is 25 meters per second? Nasaan daw siya nung ang speed niya ay 25 meters per second? Sa letter B, ang given lang natin is VF na 25 meters per second at saka VO. Okay. Na 15 meters per second. Ang hinahanap is nasaan siya. Okay, wala tayong time. So, ang gagamitin nating formula is yung VF squared equals V0 squared plus 2A acceleration x final minus x initial. Okay? XX. Yung x dyan is for the direction only, ha? Okay, so meron tayong given na 25 meters per second. Tingnan natin yung significant figure. Okay. Squared equals VO natin is 15 meters per second squared plus 2 times acceleration of 4.0 times XF. Okay, and then the initial na 5.0 meters. Okay. So, given that, ayan, 25 squared equals 15 squared plus 2 times 4 times alpha x minus 5. Shift solve. 55. Okay. Yung final destination daw niya ay nasa 55 meters siya nung speed niya ay 25 meters per second. So, yan. That's the final answer. Okay? So, next, okay na yung example number 4. Dito na tayo sa example number 5. A motorist traveling at constant 15 meters per second, about 34 miles per hour, passes a school crossing where the speed limit is 10 meters per second or about 22 miles per hour. Just as the motorist passes the school crossing sign, a police officer on a motorcycle stop there starts in pursuit with constant acceleration, which is 3.0 meter per second squared. How much time elapses before the officer passes the motorist? At that time, what is the officer's speed and how far has each vehicle traveled? Okay. So, anong gagawin natin? Ang gagawin natin, guys, tingnan muna natin yung problem. Sabi niya, a motorist traveling, ito si motorist. Okay. A motorist traveling at 15 meters per second. Okay. Where the speed limit is 10 meters per second. Dahil lumagpas siya sa speed limit, hinabol siya ni policeman. Okay? Na nakastop dyan. Okay? Ito yung initial position niya. Tapos, ang acceleration ni police ay constant acceleration at 3.0 meters per second. How much time elapses before the officer passes the motorist? Okay. Pag sinabing passes, ibig sabihin magkasabay na sila. Yan. So, ibig sabihin si motorist at saka si policeman ay nasa iisang distance. Tama ba? Okay. So, dapat nasa iisang distance sila. Ano daw yung time nun? Okay? Ano daw yung time nun wherein magkasabay sila? So, parehas, ibig sabihin si XP at saka si XM ay equal. Ngayon, let's compute for XP muna. Meron tayong formula na X is equals to XO plus VOT plus 1 half AT squared, diba? So, si XP ay XO plus VOT plus 1 half AT squared. Ngayon, si XP, si policeman, ay nakastop. Okay. At ang initial position niya, iset na lang natin as 0 kasi walang binigay. Okay, 0. At nakastop siya, so ibig sabihin ng initial velocity niya ay 0. Okay. Plus 1 half at ang constant acceleration niya ay 3.0 meter per second squared at time 0. Ay at time squared. Hindi natin alam kung kailan yung time na magkasabay na sila. Ngayon, si policeman naman, XM equals X0 plus V0T plus 1 half AT squared. Si motorist pala, sorry. Si motorist, ang XO niya, sabihin na natin, ang XO niya is nung nalagpasan niya si policeman. So, 0 na lang din. Plus, ang VOT niya, di ba, kanina pa siya umaandar. Nung nalagpasan niya si policeman, ang velocity na niya is 15 meters per second. Kasi hindi naman siya galing sa stop. Okay? Then, hindi natin alam yung oras na magkasabay sila. At dahil constant acceleration, constant ang velocity, sabi niya dito. You have to take note of this, okay? Sabi niya, constant meters per second. Pag constant, ibig sabihin wala siyang change of V. Diba? 0 yan. So, ibig sabihin, 0 din ang acceleration mo. So, anong mangyayari? So, dahil 0 na to, okay, 0 na yan. Ang XM natin ay 15 meters per second. T na lang. Okay? At ang sabi natin kanina, para magsabay sila, dapat si XP at XM ay parehas. Okay? So, equate natin. Pero ang XP natin ay 1 half 3.0 meters per second squared T squared at ang XM natin ay 15 meters per second T. So, baba natin yung isang T. This is T. So, magiging 2 times 15 meters per second over 3.0 meter per second squared. Okay. So, that is 2 times 15 over 3.0. Okay. So, that is 10 seconds. T is equals to 10 seconds. Okay? So, that's it. Yan na yun. And then, letter B. What is the officer's speed? At that time, dung 10 seconds na nung sabay sila, what is the officer's speed? Officer, so si XP. Okay? Ano daw yung speed ni officer? So, speed is VF is equals to V0 plus 80, diba? So, VF, ang V0 galing sa stop si police officer. So, A is 3.0, okay, meters per second squared. Then, T is 10 seconds. So, ibig sabihin, 30 meters per second ang speed ni policeman nung nilagpasan siya or nagkasabay sila. Okay? 30 meters per second. And then next, how far has each vehicle traveled? Hinahanap naman yung X. Okay? Hinahanap si X. Gano daw yung saan daw sila nagpang-abot, anong distance. Okay? So, solve na lang natin dito sa gilid. So, masosolve natin yan is X, diba may formula na tayo kanina? It's either pares lang naman 15 meters per second times t. Okay. X is equals to 15 times 10 seconds. Okay. So that is 150 meters. Or pwede rin natin gamitin to. 1 half 3.0 then 10 squared. Okay. So that is 1 half times 3 times 10 squared. Okay, 150 din. Okay, syempre equal lang nga lang sila. So, nagpang-abot sila at 150 meters. Okay? So, that's how you solve that one. So, next is free-falling bodies. Okay. So, sa free-falling bodies, I will discuss in the next video or the part 2 of module 2 lesson 1. So, thank you for watching guys and God